Okay, now we have some side notes for the weighted least squares, prediction, and some other uses. So it's kind of a warning when you do prediction with weighted least squares. So remember that for prediction intervals, the standard error is a summation of two terms. The first one is the variance from the under the square root is the variance of the future data, where is the uncertainty from the data, and the variance of the fit, where is the uncertainty from the fitted line. So when you do R to compute, when you use R to compute this prediction for a weighted least square, it assumes the variance of the future data is sigma square instead of sigma square over your weight. And this weight is for the future value. Remember when we do the example of the cleaning data, that when we get the prediction, we have to multiply this this weight back. This weight is for your prediction data. So depending on this, how big your weight is, if either this weight is over 1 or below 1, this can make the prediction intervals either too large or too small comparing to the true prediction interval. So this is something to pay attention, but yeah, so when you do R will give you a warning like this in red. So it says assuming constant prediction variance even though model fit is weighted. So when you do prediction, you have to convert it. Do not forget to transform it back to the original scale. So this is about prediction, and also for the leverage for weighted least squares, we can show that the fitted value for weighted least square can be written as this. So we have this HWII, which is the leverage for the weighted model. Yeah, very similar as before. And for this W, okay, yeah, this WJS is from here, and this HWIJ is actually like this. Yeah, and we can get the value, the formula for this leverage value for the weighted model, for the weighted least square model. It will be like this. So if all the weights are equal valued, this go back to the original leverage formula for least squares. So this is another connection. Okay. The next is about the weighted least squares residuals. And the residuals is like this, and this is consistent with our previous definition of the WRSS, weighted residual sum squares. So yeah, this is the residuals for weighted least squares. Okay, there are some other usage cases for the weighted least square model, and it's very much commonly used in the special case when yi is the average or the median of some summary of ni objects. So you have different groups corresponding to different value of yi. So that is variance of yi would be, I think this is for the average case, averages cases, where the variance of yi is proportional to 1 over ni. And in this case, we'll take this wi equal to ni, and it kind of makes sense. So if a data point is from n equal to 200 would be more important than like twice as much impact on the model as the data points from a group of n equal to 100, right? So we just operate the weights that incorporate the number of observations as a weights, and we use this information in the model. So this is one usage, and okay, another usage for weighted least squares, it can account for data quality. So if you have some sort of measurement of for every observations that tell you something about the quality of the data, now you can use the weighted least square to build your model so that you get a more reliable kind of data into your model. For example, if I'm building a model with information from CT scans and radiation physicist, tell me that observations that comes from scanner brand A are more reliable than observations from scanner brand B, then I can use a weighted least square model to probably give more weight for the data from scanner A and less weight to the data from scanner B. So that way incorporate that data quality issue into our regression model. Okay, yeah, some summary here about weighted least squares. What are the pros? So if we know that the standard deviation of the error is not constant, by using this WLS, this different weight that we can adjust for this issue. And as we just mentioned, WLS, weighted least square, allows you to handle the data of different quality or when they comes from populations of different sizes. Well, there are also some cons for a particular model type, right? Like least square, just like least square models. WS weighted least square is sensitive to outliers. And the theory behind this method, behind all the derivations, assume the weights are known exactly. So if you, it's important to estimate the weight pretty well. If you have the variance for extreme value of x and y is estimate use only a few data points. That means your estimate is not really reliable, right? Then it's really a bad idea to use that weight into your weighted least square model. Outliers, pay attention. If your outliers may not be good to use weighted least square, and you have to be able to estimate this WI really well in order to use it, use the weighted least square well. Okay, we will have another example to go through the used case when your data is associated with your data size. In this case,